My name is Marco Kuendig. I'm the CTO at Copebit, and what Copebit is, you see that here. So Copebit is an AWS Advanced Consulting partner. We have been around for roughly 8 years, around 30 people, and we work every day with AWS and have a lot of happy customers working with us on AWS. So we do everything that you can do on AWS, which is infrastructure related, and we really love Kubernetes. So we do CI/CD, infrastructure as code, serverless applications, to host them on AWS. And if we talk about platform engineering, of course, this is a CNCF talk. Everything is about Kubernetes. So we do platform engineering to give the developers the freedom to deploy their applications onto a platform without having to talk to the infrastructure folks. That's the aim of the whole thing that we want to achieve. And most likely you have heard the last couple of years quite a bit about platform engineering, but I want to showcase you how we do it on AWS to get the most benefit in a pragmatic way, so that even smaller companies could do something like that very easily on AWS. So what is platform engineering? As a short recap for those that haven't heard it. So platform engineering is basically offering the infrastructure in a way that developers can use it very easily, bring their code onto the platform, deploy it, and it just works. So to make that happen, we need to make the complexity of the infrastructure in a way that the developers doesn't see that. So we have to automate everything. We have to model every service in code, and we have to offer that as a service so that it can be very easily be consumed over the Kubernetes API. So basically, we have then a developer portal where we expose the reusable components like the frameworks, programming language frameworks like Java and Node.js and stuff like that, and tools and platform services like databases and caching and Kubernetes and compute and search and stuff like that in a very easy way. And of course, there is also a lot of know-how integrated so that when somebody wants to deploy an application onto the platform, that it just starts to work in a way that is adapted to the platform. Oh, it shut down. Okay, good. So basically, we abstract away the infrastructure from the application. And what we also see is that the infrastructure is handled by the platform teams, and the application teams, the product teams, the service teams, they can come and deploy onto that platform very easily. In best case, there is a developer portal where they can go in or in a programmatic way and select their programming language, prepare the platform, and then drop the code into the source code management system, and then it starts to work, deploy the application in a way that is adapted to the underlying infrastructure that you have. So the benefits of platform engineering, you have heard that many times, but I say it in the context of AWS. You get really a lot of scalability and elasticity if you build it right. Because on AWS, we can have now the ability to scale almost any service in a way that is necessary. Imagine if your developers start to laugh. If your developers start to love the platform and start to drop many microservices, many applications onto your platform, then it needs to scale. If it doesn't scale, you need to do manual capacity management, which is very cumbersome and not cool to handle that. If you have an elastic infrastructure, which I'll show you later on in the demonstration, you get very good resource utilization. So you don't over-provision your infrastructure. You apply the resources that you need, the CPU, memory, disk, caching, search, and all of that in a way that it just adapts to the demand that is coming in. And that is not only what it is actually deployed, it is also to the end user demand. So if you got an e-commerce solution running on that platform and you got Black Friday, it should scale automatically as well. So that's an aim that we want to have. And of course, everything needs to be automated. So everything needs to be encapsulated in API calls, in Kubernetes manifests and CRDs that you can very easily use that. Because you do now everything in code, you get a lot of consistency. So consistency across the environment. So you you deploy something onto development in a way, and it works then, and then you start to promote that to the stages, to test and production. You just do small changes, and then all the stages look exactly the same. And of course, there is a lot of developer productivity that you can enhance. So if your developers don't have to talk to the security guy, to the infrastructure guys, and just use the platform, and the platform is engineered that it is according to the compliance things, that speeds up application development massively. Of course, the platform needs to be built highly available and resilient. So everything needs to be multi-AZ, maybe even multi-cluster that you do, but inside of the region with multi-AZ, it just needs to work in a way that all the services that you consume are highly available, and in the background that the backup is there, disaster recovery is there, that the developer doesn't have to do such things on his own. And of course, also monitoring, tracing, and logging should be done automatically out of the box. So if you deploy an application, you expect that it shows up in Grafana, in CloudWatch, in whatever tools that you use, but not only for metrics and logs, but also for traceability or even APM solutions that you want to have it integrated, and that can be now achieved. How are you doing that on AWS? I need to look a bit closer here. On the right-hand side, you see the resources. So the resources that we need to run the actual application. So we need compute, we need databases, we need search, we need caching, and all of these things. And these are the underlying resources that we use to create the platform itself. Of course, you need a network, you need load balancing, you need Route 53 entries and stuff like that, certificates. All of that need to be there and ready to be used. And for secrets, on AWS, we got AWS Secrets Manager, so we can integrate, for example, database passwords or created secrets that you need for your application or Stripe or any third-party API calls. You can, as a developer, launch these secrets into AWS Secrets Manager with the integration of the Kubernetes API. I talked about monitoring and logging, and AWS has with CloudWatch a solution that is good enough. It's not great, but it is good enough, and it comes at a relatively reasonable price. So we got logs and metrics and APM and tracing, all of that integrated into the CloudWatch suite. Now let's go a step up into the operator. So the operator is, of course, the platform operator, of course, is Kubernetes itself. So Kubernetes, everyone in here uses it and knows how good Kubernetes is. But we need to extend it with a few features. So we need to get GitOps principles in there so that we really can work with Git as the single source of truth. And we have opted for Flux, but you could also use Argo or any other solution that you would like to use so that we get a really close link between the source control management and the Kubernetes cluster state. One critical feature so that we can really deploy external things from the Kubernetes cluster is crossplane. So crossplane is not so well known. Crossplane is an operator that actually gives us the ability to integrate into external services. And I have a dedicated slide to crossplane later on. Of course, we need the images, we need the CI pipelines, and there can be GitHub, GitLab, whatever you want to use to build the container images, to test and scan these things, of course. And then source control management, that's super important. So here, GitHub, GitLab as well, so that you can store the code and have proper source code management features involved. And then I mentioned before a developer portal that could be Service Catalog or any other solutions that you could use as a developer portal to actually have a user interface for the developers to see and browse what is available there. And then to deploy everything onto AWS, we use Terraform. Can also be Pulpulumai or something like that, but Terraform or Tofu these days is quite good to deploy stuff onto the AWS infrastructure. So now let's go into some of the features to explore that a bit more. Who of you has worked with GitOps principles already? A few of you. So for those that don't have, so the big two players are Argo CD, that's probably the biggest, very big thing, and Flux. Flux is a bit smaller, a bit more pragmatic, and Flux is very easy to use. So with GitOps, you get the ability on the left-hand side to use your CI pipelines to do the building, the testing, the scanning, so that your images, container images, are prepared and pushed up into your registry so that you can use them. But you also have in there, you have your Helm charts, your customized scripts, whatever you use to deploy onto the Kubernetes cluster. Now with GitOps coming into play, with Flux, for example, you scan the repository for changes and then put that as a deployment step onto the Kubernetes cluster. So that is then deploy, observe, and operate and fix in a reconciliation loop. So on the right-hand side, we always go through a loop and see that what is in Git is also deployed on the Kubernetes cluster. And that brings us now into a point where we are 100% sure what is committed into the repository is actually deployed on the cluster. Because everybody of you knows it's so easy to go and do a change, or it's so easy to do a small change in code, deploy it, but forget to commit it. Or you have something in Git and you don't know if it was really deployed or not. With GitOps, you are sure what is in the source code management system is actually on the cluster itself if the system works. The best thing here is, if it's configured correctly, you can actually revoke your developers' access to the Kubernetes cluster, because there is no more need for kubectl apply. That is all done via source control management. And there you have perfect features for merge request reviews and approvals and all the workflows that you can have there to properly control what is actually deployed onto these systems. Now going to Crossplane. Who of you have worked with Crossplane? Probably only a few. Yeah, because it's relatively new. So Crossplane really helps us out of the Kubernetes cluster to talk to the outside world via providers and do stuff, for example, in the AWS cloud. So here examples could be your developer needs a DynamoDB or an S3 bucket or a certificate or something else. And the Crossplane actually can encapsulate these services and provide them as Kubernetes APIs. And then you can very easily consume them. And I'm pretty sure you already had that problem before. How do you bring certificates and DNS names and S3 buckets without having to talk to the infrastructure team? And I know there are solutions like external DNS and cert manager and stuff like that. But in enterprises, Let's Encrypt certificates are not so well seen, or wildcard certificates. So there it's probably be easier if you just get a certificate from a proper location and import that. And with Crossplane, you have now the ability to say we have a DNS record, a certificate, a S3 bucket, a DynamoDB as an object in Kubernetes, and then your developer can provision that object and it is automatically created. And it's a two-way communication. In an extreme case, Crossplane could also deploy Terraform. But then it's that abstraction over abstraction over abstraction. So, but he could do that. I'm not a fan of that, but you could do it. So I rather work with the small providers that interface natively. That's much easier. Tend to go through multiple abstractions at the same time. Observability is also a pretty big topic. So if you want to have proper deployments of applications, you need to have the metrics, the logs, the traces, APM information, so that your developers are really sure what's going on. On the AWS side, a lot has happened, so that in the container world, it gets better and better. And AppSignal is now a tool that gives us APM-level capabilities that you can use. So AppSignal is not New Relic, but it is also much, much cheaper. And usually it is good enough. So it uses X-ray in the background, and it really integrates into your applications to have service-level tracing and visibility on the AWS platform itself. So you don't need to have 4 or 5 different solutions to get all of that information. You can have it all out of the box because you anyway have metrics and logs already there. Now you get traces on the APM information as well with CloudWatch app signals. Here is how it looks like. So first it creates a graph. So you see your local resources in the Kubernetes cluster, but you also see DynamoDBs and other external resources, because AppSignal can also talk to the AWS API as well. And here you see some of the metrics that you can get. So you see on the right-hand side, all the transactions are listed. You see also the status that is going on there. So you get a lot of visibility into your application and your microservices out of the box without doing much with your platform that is built up. I mentioned before, if you build a proper platform and you open that up to your developers and they have a lot of freedom, you really need to build it elastic. And we can build it elastic with auto-scaling on all the services that we need. So you all probably know VM auto-scaling. That has been around for a long time. So you have a load balancer, you have the VMs, and you consolidate the traffic on the load balancer. Now what you do is you put a metric onto the monitoring, and then you scale based on load. So that could be CPU, memory, amount of connections, stuff like that. And then you scale out on EC2. Of course, we now need that as well on the Kubernetes cluster. And with the Kubernetes cluster, we have something that is called Carpenter. Carpenter is a really great auto-scaling solution on Kubernetes, because it scales much faster than the classic auto-scaling groups that we had before. Carpenter scales within roughly 45 seconds and integrates really good into the AWS API to get price information, AZ information, spot information, and gives you the cheapest resource for your needs right now. You can also do that with databases. So if you use, for example, Aurora databases for Postgres or MySQL, it can very quickly scale. So it can scale now within 100 milliseconds, depending on the load that is coming in. So here you see the blue line is the demand that is coming in. So you see we start really with a low capacity on the orange line, and then it scales up very quickly within seconds to meet the demand, and then it scales down again. That is using the Caspian technology. Caspian is actually hot adding CPU memory into the instance, and because of that, we can really quickly add that capacity in roughly 100 milliseconds, where we can add capacity into it. And of course, scaling down is much slower because we need to wait for a failover window. We cannot remove memory from a running instance. You can also do that for caching. Here the same technology is used for Redis, the Memcache. Also Caspian is used, and very quickly where you can go up. So that's called Elastic Cache Serverless, and the same technology is also there for OpenSearch or also for Kafka. So you have now a lot of solutions that are used out there that you can use. And here is a small summary what you can build Elastic today, because that's a really important feature of your platform that you need to build in. If you don't have elasticity, you start to manually manage capacity, and that is really hard to achieve. Good, and now I have a small demo. I have about 10 minutes left, so let's see if I can get this working, everything correctly from the beginning. We stopped the presentation with elasticity. So, and I want to show you now a very quick Carpenter demo where I have a deployment which is right now not scaled. So I'm simulating an auto-scaling event on the pod level. So I'm going to scale that deployment. Before I do that, I need to give you a quick instruction because it goes really fast. So you see here, ignore the Fargate pods. They are not important. They are for the platform. You see here we have one node that is actually running something. There is a bit of space left in terms of CPU. But now we are going to launch 10 additional replicas. So that is filled up very quickly. But we also got 6 pending pods. If we go over here, you see we got these pending pods. Now, if we go back, we will see that within roughly 40 seconds or something like that, the Carpenter agent that is running on the cluster itself talks to the AWS API, sees which is the cheapest node right now, and then it will launch a new node. So you have seen that here within roughly 40 seconds. So that node is now joined to the cluster. It takes a a few seconds more to get the pods running. But here you see now the pods are running, are scheduled. And if I go over here, we see the containers are creating. And of course, these are easy containers. They launch very quickly to speed up the demo. And now the containers are all running. The node is up there. Now let's do the scaling down. So you see, I scaled down the deployment to 0. The pods are deleted. The node is empty, and it takes about 30 seconds to delete that node and put it back into the capacity of AWS. And of course, you only pay the capacity that you are actually consume. And these are spot instances. You don't see that right now, but spot instances can be used very easily because Carpenter is on demand and spot and AC aware and also storage aware. So you see it has been deleted very quickly. Of course, you need to engineer that correctly so that you don't get a flapping cluster, but this is a really cool tool. Very, very quick demonstration. Now let's do the demonstration on the database side. I'm using Sysbench. Sorry, that's MySQL. Postgres is much better, but here for the demo, I use MySQL. So here I'm going to stress this one. That's the right command. I need to copy that one, put it up here. And what this Sysbench is doing now, it's simulating 100 threads, 100 clients talking to the database that is there. The database is an Aurora Serverless v2. Let's go over here. So you see the Aurora Serverless v2 is between 1 and 32 compute units. A compute unit is one CPU, one virtual core that we are giving it. So now let's go to monitoring. We are going here. I'm opening up this one here. I'm changing here to very quick 1 hour, and I want to update here. So you see right now we have one capacity unit running, and the pod is actually stress testing that Aurora. So what happened now is you don't see it because there is a monitoring lag, but actually what happened is Aurora has already scaled up. And if I talk a bit more, you should see then here, maybe in 30 seconds or so, that it actually goes really up. But in the meantime, let's go to see what the stress testing says. So we started at 140 TPS with the initial 1 CU. And now after 70 seconds, we already have 3 times the capacity, 320. So the clients are really getting much, much faster reactions. And here you see the proof. It scaled up to 6 compute units because I don't have time. I can't wait here. But actually, it will scale up to about 15 or so, and then scale down after the load has disappeared. Now let's go to the next demonstration. So that is all about Flux and now. So I exit here. I'm going to launch K9S here. Yeah, that should work. Maybe it's a bit small, but let's see if that goes. So here we are in the default namespace. So Flux is now configured to listen onto an empty branch. So I will switch branches because it's much faster than to do merge requests and stuff like that. But basically, I will simulate some changes in the source code management system. So Flux is connected to our Git lab that we have. And I'm going now to install, which one is it? Not this one, empty, or this one. So I'm now switching to the pod info branch. So the pod info branch got the Helm releases and other stuff in there to launch a Helm release of pod info, which is just a small pod that is launched. And you see within a couple of seconds that Helm release is done and installed. So now let's go over to GitLab so that you believe me that this is really hooked up. So here I am on the branch, on the repo, on the branch, and I'm going in here to do a change. So I'm going to change the replicas, and I'm going to, it's not best practice, but I'm going to commit that straight to the branch to speed up the stuff. I commit and push. I go back. And here what you should see, after the reconciliation loop has started to kick in after a certain interval, that there should be more pods coming in. It takes about a minute or so. So Flux is having a reconciliation loop that actually goes into the Git repo and always checks if there are changes in the Git repo, if there is a merge request or a commit or a push or anything like that. And then it actually recognizes these changes, does a diff, and applies that to the cluster. And of course, I missed the last interval, but it usually is really quick to launch that second pod onto the cluster itself. Maybe it's already here. It's already here. It's a bit small. So you see, it has already launched. I only recognized it because of the tree up here. So it's already there, and the change has been applied to the cluster really quickly. Now let's do a full-blown test. I still have 3 minutes left, so that should work out. I'm going now to do the change to install WordPress onto that cluster. We don't love WordPress, but it's always a great demonstration application. So we are going to put onto that cluster WordPress. And WordPress, of course, has multiple requirements. Where is it? I don't see it, sorry. Here. So you see, I changed the branch to WordPress, and in WordPress we need a Helm release, we also need certificates, we need DNS entries, and more. And that's how I showcase you now how we are going to deploy stuff from the Kubernetes API onto the AWS console. I was too slow, sorry. This time the cluster was faster. So here it has created a certificate. So we use an ingress with a certificate, a proper ACM certificate, but I can prove that you with the time. Where is the time? Here, 18:43, 31 seconds, that's right now. So that certificate was created. So the cross-plane API AWS provider for ACM created that certificate for me, because we encapsulated the certificate as an API call on Kubernetes. And the same happens here with the load balancers. So load balancers are no problem with Kubernetes. They have been around for a long time, but the ALB controller, that is also done at the same time. But now something more complex. We are not using external DNS. We are using here the cross-plane Route 53 provider to actually configure a DNS entry and hook up the load balancer name in the DNS. So hopefully, yes, it already worked, because we had 4 before, and now I have that WordPress already in here. So here the ALB, it's a bit small now, I made it bigger so that you can better see it. So the 78DB is actually the load balancer that was created, which is that one here. So the two-way communication between the provider is shown here. So we create a DNS entry based on something that is available in the load balancer. So all is two-way in the API. So now let's go, hopefully, when I copy that one, let's see what happens here. Sorry, I need to switch around quite a bit. So the load balancer needs about 3 minutes to come up. So but the DNS name is already there. So let's see. I put that in, and I was super lucky. I talked enough. So WordPress is already there. And this here has also a proper certificate. So if I go to the certificate, you see that's exactly the certificate that Crossplane configured. I also configured right now. So that 1.0, that is really right now. That's a certificate that we have configured before. And now the last thing that I want to show you, it's not only building up stuff, it's also cleaning up stuff. Where is it? The empty branch. I can do pod info, it doesn't matter. So it's also cleaning up stuff. So I switch it back. So WordPress is deleted. The Helm release is gone. All the Kubernetes resources will be deleted. And what we will see is the certificate should be deleted in a couple of seconds. The Route 53 entry should be deleted. So you see here the records went down to 3. It's deleted. Certificate, it's not yet deleted. Of course, it will come soon. Here it is deleted as well. The load balancers are deleted. All is gone. So it's not only deploying, it's also cleaning up in a declarative way that we have done. And with Crossplane, you can interface in any cloud into any solution that you want. And if you don't have it, then you can use the Terraform provider if you really want to do so. Good. So that concludes my demo. I'm almost on time. Thank you so much. Any questions?